Hi, this deck of cards was compiled to facilitate working through problems dealing with vectors and their components, specifically standalone questions. In the formula for electrostatic force, where Q is a test charge, Q is the source charge, and R is the distance between their center of masses, R has an inverse S blank E relationship to F. So what type of relationship does R have with F? That's an inverse square relationship. So there's the inverse square relationship, V1 over R squared. Draw the force vectors of the forces exerted on charge A. So what will the force vectors look like? I'll give you a moment. Seeing the force vectors, let's make sense of them. So here we have the charge of interest, QA, and because QB is a positive charge, it makes sense that A would be attracted to B, to the right. So the force vector, it makes sense that it points in the positive rightward direction. And because C is a negative vector, it makes sense that the resultant force is in the negative direction or the leftward direction, because like charges repel, so the force is going to be repulsive. And lastly, because QD, or QA, but meant QD, because QD is positive, there's going to be an attractive force. So it makes sense that that resultant force vector is pointing north or in the upward direction. If the force of charges B and D on charge A are each 1 unit, so these are each 1 unit, then the force of charge C has 2 negatives, will be blank units. Think about this carefully. I'll give you a moment. One half is the answer. What you have to remember is that F equals Q, test charge, times Q, source charge, over the distance between their center points squared. So if we take the test charge to have a charge of -1 units, we're just going to consider the magnitude 1. And then Q, that would be our QC has a charge of -2, but we'll just consider the magnitude. And then if we consider the distance from A to B as 1 unit, then we can consider the distance from A to C as 2 units. So the radius is going to be 2 squared. The distance between Q and C is double Q and B. An increase in the radius. So with an increase in charge, the new factor that is going to result is 2 over 2 squared, or 1/2. okay? So basically, you end up with a 2 over 2 squared, and you simplify it to get 1/2. And that's the answer. If you are told that theta equals the arctan of 1.33, 1.33 is the value of the blank side divided by the blank side. So take a moment to think, and what's the answer? Okay, it would be the opposite side over the adjacent side.
Of 1.33 equals theta is a very special value because the arctan of whatever value is within the parentheses, this value represents 1.33 equals the magnitude of the opposite side over the adjacent side.
Opposite side.
But we can do some very special things with this value
Adjacent
because
side.
1.33 is really
adjacent.
another way of saying 1 and 1/3. Because if you review decimal to fraction conversion, 33 out of 100 is 33% or 1/3. Okay? And another way of expressing 1/3 is to multiply the denominator by 1 and add it to the numerator is really 4/3. So basically 4/3 equals
I meant to say 1 and 1/3
side over the adjacent side. Okay, but we also know that a right triangle,
opposite,
adjacent, that has 2 legs with the value 4/3, with the
and this is a right triangle,
and the adjacent being 3, is a 3, 4, 5 triangle. So therefore the hypotenuse is 5. And then when you have an orientation like this, like the one that's given to you in the figure, it's important to realize that this diagonal leg is really the same length of the hypotenuse, because if you were to flip it
but this is actually wrong.
Like, I don't know, do a diagonal flip, I don't know what to call this, you would get that, okay? And the change in x would equal sol. And
it's actually a flip and a translation, a shift to the right.
This is really just like a weird reorientation of the hypotenuse. It's hard to prove that, but if you start at sol and end at
it's a flip about the
change
x-axis, and then a shift to the right.
Sol, and the change in the y is equal to Lorenzo. They're both negative, but the x's values vary when it comes to assigning the negative sign. So this could really be related to a 3, 4, 5 triangle. So basically, if the hypotenuse is going to be 5, and the side opposite theta here is the height, and so the height here is going to be Lorenzo. So we could say that this side is proportional to 3. That would mean sol is proportional to 4. But if we know that the magnitude of Aisha,
that side is actually
really
proportional
20,
to 4, and the x-axis is proportional to 3.
4, so you multiply everything by a factor of 4. And then you get the actual length of the sides, okay?
Sorry for that lengthy explanation, but so if you flip Aisha about the x-axis and you shift her to the right, you'll perfectly overlap.
Saul and Lorenzo, and that's why these triangles are basically equivalent right triangles.